All right, so we're going to continue with the heart of algebra. Today we're going to review graphing linear equations and then also looking at some word problems. So a few things to keep in mind when you're graphing a linear equation is that if we can get it into slope-intercept form, we have our equation here, y equals mx plus b. M is always the slope, or that rate of change, and then b is always the y-intercept, which is where it crosses the y-axis, where it has an x value of 0. And that's just talking about kind of the start value of the equation. Some other things to keep in mind: parallel lines have the same slope, and then perpendicular lines have opposite reciprocal slopes. And then we have those special cases of horizontal and vertical lines. So vertical lines are x equals a number because it's telling us that no matter what y is, x is always the same value. And then the same thing with horizontal lines. It's y equals a number because no matter what x is, y is always the same value. So here's an example for us. It tells us about the value of a bond on January 1st is $1,000. And then each year the value of the bond increases by 75. So we want to figure out which graph represents that scenario. So we're looking for basically the start value of the bond is 1,000. So this is our y-intercept, or b, if we needed to say model an equation. And then it's increasing linearly by $75 each year. So that means that our slope is 75. So we just need to figure out which of these equations models this scenario. So if we look at our graphs, a y-intercept of 1,000, this graph doesn't have it. And this one's kind of cut off, but this one doesn't have a y-intercept of 1,000 either. This graph here has a y-intercept of 1,000, and so does this one. So then we want to figure out which one of these two graphs has a slope of 75. And so they're both positive, just trying to take a look at which one might match that 75 for slope. Here in this graph, if we try and find our slope or our rise over run, if we go 2 units in x, so that would be our run, I should probably put it over here. So 2 units this way, and then our rise, this vertical distance, just be careful. It's not 1 unit like it looks on the grid. If we look at the y-axis, that's really half of this distance from 1,000 to 2,000. So it's going to be 500. So 500 over 2, well, that's 250. So that slope's too steep here. But maybe if we tried this one first, we could kind of get the same idea. But in terms of estimating your slope, I would pick values that are easy to see from the graph. So maybe kind of coming over here and then up to here. So our vertical distance, that one block, again, is 500. But horizontally, we're going from 1 to 7. So our rise over run is 500 over 7. And that's not exactly 75, but again, we're just estimating from the graph. This is 71.4, so that's closest to the 75. So this would be our correct answer choice. So here's another one. We've got another equation. We want to figure out which equation represents the line. None of these are in y equals mx plus b form. So we can do a couple of things here. We can solve these for y equals mx plus b. And so, for example, for this first one, that would look like moving the x over. So 6y equals negative x plus 1, and then dividing everything by 6. So y equals negative 1/6x plus 1/6. And so here, that's not going to be it because our y-intercept is 1. So we know that choice is incorrect. Over here, we can do the same thing. We can move that x over. This would then be 6y equals negative x plus 6. Divide everything by 6. We get y equals negative 1/6x plus 1. Well, that does have a y-intercept of 1, and it also has a negative slope. We need to then check and see if it matches with what's here. So our vertical distance here is 1. Our horizontal distance is 6. So 1 over 6 does match for the slope. Another way you could go about checking here is that you could just pick some x and y values and see if plugging them in works. So like if you picked this point here, you could say, okay, x equals 0, y equals 1, and plug those into the answer choices to see if it's a true statement. So like here, I would say 0 minus 6, that doesn't equal 1. So that would eliminate that choice. Or here, 0 minus 6 is in fact -6, but then maybe we need to pick another point and see if that would work. So maybe picking this value here of x equals 6, y equals 0, to see if that would work. And so here that would give us 6 minus 0, which doesn't give us -6. It would give us +6. So that choice is out. So if you're going to use the selection method this way, you do want to make sure you pick at least 2 points, because this equation would just be a line that would pass through in a different direction with an opposite slope. Here we have a scenario where we're looking at the word problems. And so here they're talking the bookstore charges $60 for a yearly membership. So that's kind of your flat fee or your intercept. And then it says the first book is free, and then everything after that is $7.60, including tax. So this is your rate, but we do have to take into account that the first book is free. So in terms of trying to figure out which equation would model that scenario, it's not going to be this one because it doesn't have a y-intercept. This is just saying that we're charging $7.60 per book, no membership fee. So that first choice is out. Here, this one maybe looks a little more complicated, so maybe we'll hang tight on that one for a minute. This next one has that start fee, but it's costing you $7.60 per book, but there's no free book. So this one's not it either. So now we're down to these last two choices, which maybe are a little bit more complicated. This second one that I skipped for a minute, this is saying $7.60 per book, but it's one book fewer than you purchase. So here it is accounting for the first book being free, but not the membership fee. Whereas this last one saying $7.60 per book, but that first book was free because we're taking it off, and $60 membership fee. So that last one is the correct choice. Okay, so here's one more scenario. I'll give you guys a second to read this one. It's a little bit longer. Okay, so we want her distance as she's walking home. And so maybe you're looking at this on the SATs, you're running out of time, and you just say, I don't have time for this, and I want to guess and move forward. Well, we can narrow down our choices a little bit. So here it's saying she's 1.4 miles away. That's your start value. So that's your intercept or your constant term. They all have a constant term of 1.4. But as she's walking home from school, she should be getting closer and closer to her house. So if she's getting closer and closer to her house, that distance is going to decrease. So here she's starting at 1.4 and she's taking distance away. So she's getting closer and closer. Here she's adding distance. So that doesn't really make any sense if she's supposed to be walking home. So now we're down to a 1 out of 3 shot of getting it correct instead of a 1 out of 4. So you're increasing your chances just by using a little bit of common sense, and then you can guess if you're overwhelmed by this question. In order to kind of take a look at what would work, maybe you're still kind of overwhelmed with it and you don't really know where to go, you can think about what might make sense. So here the problem tells us that it takes her an average of 24 minutes to get home. So that means that if the time is equal to 24 minutes, then the distance should be equal to 0. So if we take that idea and plug into these answer choices, we should be able to figure it out. So for this first one here, if I say 1.4 minus 7 over 120 times 24, if I take 7 over 120 times 24, that gives me 1.4. So now I have 1.4 minus 1.4, and she's at home. Her distance is 0. So that first answer choice is correct. Whereas if I did that for the other ones, here if I plugged in 24 minutes for her time, 24 times 24, well, if I subtract that from 1.4, I'm going to get a negative value, which told me that she went way too fast and she got further than her home in that 24-minute time period. So that one's out. And then we can do the same thing here. If I do 120 over 7 times 24, again, that number is going to be much larger than the 1.4. And so we get a negative value for distance. So your assignment for today is the graphing linear equations and then the linear function word problems sections on Khan Academy under the Heart of Algebra. We're going to hold off on sending screenshots. Hopefully we can get it to work without that, and I'll let you know if I do need some other form of kind of proof of completion. You don't need to worry about the screenshots. We can get that in another way.